Hi everybody, I want to show you guys how to calculate the area beneath a graph. The reason why we calculate the area beneath a graph is sometimes it tells us about a specific quantity. So here we got a velocity versus time graph. We got velocity in the vertical axis and time in the horizontal axis. So what happens is this graph represents the ratio between velocity divided by time. We know that velocity divided by time is acceleration, so we know the slope is indicative of acceleration. But what happens is, what happens when you multiply velocity versus time? So when you multiply velocity times time, you consider displacement. So it's important for us to know how to calculate the area of velocity versus time graph to figure out displacement. For acceleration, it tells us the velocity of an object, so keep your eyes peeled because you're going to be using this a fair bit. A couple of equations of areas that you should remember and will help you out. Don't think that these will come up that often. Is the area of a square, which is side times side. The area of a rectangle, which is the length times its breadth. There might be other variables or terms that you guys use, but either way, you're multiplying the different sides. And for a triangle, which is half times the length times the height. So the height and its length multiplied by half. And that gives you the area of a triangle. So for this position versus time graph, you can see that I can create this triangle. Right? This triangle here is given by the length 8, so 8, and I'm going to times that by half, and I can see that the height is a value of 40. Okay, and what that gives us is a value of 160 meters. Okay, now you might have to calculate different shapes different areas. So for example, you could have a scenario like this, where you have an object that has started with some initial velocity. So now you're not only got a triangle, you got the triangle, and you got your squared area, your rectangular area beneath that. So you have to calculate that different area. So you have to calculate this triangle and that rectangle. Or you might have a graph like this, where you might give up for, you might have that happen, this happen, and this happen, right? So now you got a square, you got two separate rectangles that you got to calculate the areas for. So whenever they're asking you to calculate the area, consider how you can break that down. The other scenario that you can possibly get is when you have different areas that come up, so areas that occur below the graph. So you might have a graph that starts going into the negative values, that's positive 1, 0. So you might have this occurring, goes to 0 for a bit, and then you have a negative value. So this will have a negative value. So when you add them, you should get some kind of subtraction that occurs. Okay. So let's have a look at this one, velocity versus time graph. You can see it's going up positive direction. It gets to a maximum speed of 3 meters per second, and then it holds it for a bit. So over 2 seconds, and then by the time it gets to 8 seconds, it decides to brake or slow down, and it breaks the point. Sorry, it starts to move backwards. As it's moving backwards, it exceeds its initial position and keeps on moving backwards and backwards up until it gets up to negative 10 meters per second. So we've got a couple of areas that we have to calculate here. So we'll call this one area 1, area 2, area 3, and area 4. So we need to calculate the area of this triangle, the area of this rectangle, the area of this triangle, and the area of that triangle. Okay, so we can do that here. So the first triangle, again, half times the length, 5 times the height, 3, gives me 7.5. For area number 2, we've got a rectangle. We've got, we don't have 8. We have from 5 to 8, which is 2 units. 1, 2. So 2 times the height, which is 3. That gives us 6. We've got another rectangle. Half times 1 times 9 times 3, which is the height, gives us 1.5. Now last area, number 4, is again half times 1 times negative 3. So negative 3 is very important. So you get told that that's a negative value. So that means when you add all these up to calculate the overall displacement of the object, that subtracts and gives you a clear picture of how far that object has traveled. So if you add all those values up together, you get a total value of 13.5 meters that object has displaced.